Alright, in this video we are going to look at a special kinds of series which is called power series. Okay, so what is power series? It's a series of type, it will look something like this, a constant plus that, so on and so forth. Okay, so I can write this using this as well. K starting from 0 to infinity, a sub k times x to the power of k. So one question comes to mind: how do we check for convergence? Okay, so alright, so ratio test is something like this. So let's say we have we try to find the limit of when k goes to infinity, the limit of series. In this case, our power series is k. I'm gonna put plus 1 here, x k plus 1 here, divided by k x k. Alright, we want to look at the limit of this here when k goes to or tend to positive infinity. And another addition I will add to this one, I will add an absolute value, because we are going to see the absolute value of this. Alright, and then I will name this limit row. We have 3 cases. Okay, case number 1, when p, whenever we calculate this, we got p, sorry, not p, row. This is the letter row, the Greek letter row. If row is less than y, then the series converges. Okay, and if we have row more than 1 or tends to infinity, for example, then it diverges. Okay, the series diverge. And then if we have row equals to 1, then this is we cannot conclude anything from here, so we call this inconclusive. So what do we do next? Maybe we have to try some other test. Okay, so basically the general way to find whether a power series converge or not, we're going to use the ratio test, where we take a look at the limit of these terms, the k plus 1 term divided by the kth term, and then take the absolute value of that and find the limit when k approaches to infinity. Okay, let's look at a simple example where say k starts from 0 up to infinity. Let's look at a simple example of x to the power of k. Okay, well, the series will be x to the power of 0 will be 1, and then we have x squared, we have x cubed, so on and so forth. Okay, so let's use the whether, if we want to check whether it converge or diverge. Okay, let's use the ratio test just now. Okay, we check a row which is defined as the limit of the k plus 1 term divided by the kth term. Okay, alright, so let's look at that. Remember the absolute value. So the k plus 1 term is x to the power of k plus 1 divided by xk. Alright, so this is kind of easy, because we know that when something like this divided by x to the power of k, all we have left is just x. Yeah, alright, so this means that the value for row is the absolute value of x. So we know from the ratio test that if row is less than 1, then the series converges. Okay, so which means, alright, therefore, okay, you know that is when the absolute value of x is less than 1, then the series converges. Okay, so this here can also be written as something like this: x less than -1 to 1. Okay, because we have absolute value here less than 1, so it can be rewritten as something like this. Okay, so here we say that the radius of convergence, okay, so the of convergence is between -1 and 1. Okay, right now I know that if x, this x here, all right, if x here is a number between -1 and 1, okay, here, then the series will converge. If the number, if x here is more than 1, 2 or 100 or pi, then the series, the whole power series will diverge. But what happened when x equals to 1 or x equals to -1? So because the ratio test cannot really check that, so we have to do some test. So let's do a simple test here. We know that I'm going to use different color here. I'm going to use green. So we know that if say for example, if x equals to 1, because we want to check what will happen when x is actually equal to 1 or x is actually equal to -1. So what we're gonna have is something like this: 0 x to the power k. Oh yeah, let me write down, instead of x, then I will just write the number x, 1 to the power k. So here what we will have is, because 1 to the power of any number will become 1. Any number, any real number, positive number here become 1. Okay, so 1 plus 1 plus 1 plus 1, so on and so forth. And we know that this will tend to infinity, so this one will diverge. So we know that when x equal to 1, it diverges. What about when x equals to -1? Okay, so we want to check also. Okay, when x equals to -1, what we're going to have is x 0 will be 1, it's -1 plus 1 minus 1. So as you know, alternating series like this has no, is not converging, so it diverges as well. All right, so we know that now the radius of convergence for this power series is if the x here is between -1 and 1. Let's take a look at another example. Let's look at example where I would say okay, starting from 0 to infinity, x to the power of k divided by k. Oh wait, let's change this here instead of starting from 0, because when k is 0, then this doesn't make too much sense. Okay, so let's start with 1. Okay, I can do that. So let's find out whether it converges or diverges. Okay, so we use the ratio test again. Ratio test. All right, as usual, I'm going to use this one. All right, ratio test. I know rho will be equal to in the k plus 1 term, which is a x k plus 1 up here, divided by k plus 1, divided by the kth term, which is x to the power of k divided by k. So I'm just going to, instead of doing it down here, x k, I'm just going to skip that part, and then I rewrite that as times k x to the power of k. Okay, I'm still using the ratio test. Okay, but I've rearranged everything. So now I can say that okay, this one can cancel out, this one can cancel out. So what oh yeah, I forgot the absolute value. I need to find the absolute value of that. So what I've got here is actually okay, I have k over k plus 1, and then I'm left with just x here. All right, so what I can do here, I can bring the x out. Okay, just leave the this to the right. So I know when k approaches infinity, so I'm just going to use L'Hopital's rule here, just to make my calculation of limit easier. Okay, I hope you still remember L'Hopital's rule. What I'm going to do is I'm going to differentiate the numerator and differentiate the denominator, and then find the limit that way. Okay, so differentiating up here with respect to k, I got 1. Differentiating down here with respect to k, I got 1. So I'm left with that. So now I know that rho is equivalent to absolute value of x. It's the same as before. So we know that when rho is less than 1, then this will converge, which means that what we have right now, absolute value of x, to make it converge, then absolute value of x has to be less than 1. Okay, so which means that we have the same what we had before. I think the answer, the radius of convergence, is between -1 and 1. Okay, so this is our answer. Again, we are not too sure what will happen at -1 and what will happen at 1. All we know that any number between them, then this series here will converge. So let's check. What about, let's rewrite my question. What about -1 and 1? Okay, all right, let's check. I'm going to use different color here. All right, check if x is equal to 1. Okay, so this, what we're going to have is 1 to the power of k divided by k. 1 over 1 is 1, plus 1 over 2, plus 1 over 3, plus 1 over 4, so on and so forth. A series will diverge. Okay, now what if x is equivalent to -1? Okay, so what we're going to have is something like this. So it's pretty much the same as before, except that we're going to have alternating sign here. Okay, so we're going to have -1 plus half minus 1/3 plus 1/4, so on and so forth. So this also diverge. So we can safely say that the radius of convergence is between -1 and 1. Let's look at k factorial times x to the power of k ratio test. Okay, so k plus 1 term up here, x k plus 1, okay, and then kth term down here. Okay, so, and don't forget the absolute value. Okay, so I like this one because it's pretty easy. I can just write this, and then k, this will just live with that. So what I will get here is pretty much something like this. So I have k plus 1 here, and I have x left. So x, all right, so I can leave it like this, k plus 1 here, and then I can just leave the absolute value x outside. Okay, but now if you can see this, when k tends to infinity, this whole term here also tends to infinity, right? Then because there will be infinity plus 1, which is still infinity. So it doesn't matter what x here is, so rho here will always go to plus infinity. All right, so since rho is always plus infinity, so that means the power series is divergent. Okay, for all x, doesn't matter what x we put here, this whole term will always go to infinity. So for all x, this power series will diverge. So we say here the radius of convergence is 0. It doesn't converge anywhere. Okay, all right. So let's take a look at another example. I like to do examples so that we can sometimes see it better, how to deal with different kinds of series, stuff like that. Okay, so let's take a look at x to the power of k divided by k factorial. Okay, this means that the first one, k0, will be 1 over 1, okay, plus x to the power of x divided by 1, because 1 factorial is 1, and x will be 2 factorial, so on and so forth. Okay, now actually this is an interesting series. I'll show you later. Ratio test, it's the xk plus 1 term divided by xk plus 1. Okay, yep, okay, yep, divided by the kth term, which is k. All right, rearranging that. Okay, now as k goes to infinity, you know that this term will become really small. Okay, 0. So it doesn't matter what x is, so this will become 0. So this is nice. Rho is 0, which is always less than 1. So this means that the power series here is convergent for all x. Doesn't matter what number you put here, okay, it will be converging. So we will say here that the radius of convergence is infinity, or rather plus infinity. Okay, as I said before, that this series is interesting. You might want to check this out. You know, x to the power k divided by k factorial. Okay, this series actually is 1 plus that, okay, and so on and so forth. All right, if you continue up into infinity, because it's converging, is gonna, you know, have a sum. All right, and actually the sum is that number, e to the power of x. Interesting. In the form of x minus some number, okay, x naught. I'll show you here. What if we have, okay, before what we have is something like this, right? A sub k and x to the power of k. All right, so now what if we have something like this? X minus some number, okay, x naught, I'll name it x naught to the power of k. Let's say we have x minus 5 to the power of k divided by some k squared, for example. So this one is still a power series, but it doesn't have the form that we've seen before. It doesn't have this form here, okay, because we have x minus 5, and then the whole thing is raised to the power of k. Let's try the ratio test here, okay, to check its convergence. Well, this is actually 1. Okay, you apply L'Hopital's rule for numerator and denominator, you will get 1. This is interesting. So my answer will be x minus 5. So rho here is x minus 5. So we can say, because when rho less than 1 is converging, we can say now that when the absolute value x minus 5 less than 1, then the series converge. Okay. So if we rearrange everything, x minus 5, okay, and then rearranging again, we got here plus 5, minus 1 plus 5, got 4, plus 5, here 6. So now this is our radius of convergence. Okay, and as a homework, maybe you can post the answer below. What happened is does it converge or diverge? Okay, when x is equal to 4 and x is equal to 6. Okay, post your answer below. I leave you with some homework here. Okay, I hope you can answer that. So that's all. Thank you.